Good morning, ladies and gentlemen, and welcome to the 2024 JEC World Live demonstration area. For the next 3 days, we are going to be witnessing groundbreaking technology which is shaping the landscape for the composite parts manufacturing processes area. We are going to be exploring areas, composite parts which are used in areas such as aerospace, marine, railway, electronics, defense, and renewable energies, just to name a few. Ladies and gentlemen, this is the first time that we are able to witness such revolutionary technology at the JEC, and we are pleased to thank our partners, Thermwood, Aerovac Composites One, Magnum Venus Products, and Roctool for making this experience possible. Ladies and gentlemen, the demonstrations will be taking place in English. If you would like to have a live simultaneous translation in French, don't hesitate to get a pair of headsets from the hostesses. Mesdames et messieurs, les démonstrations vont se passer en anglais. Si vous souhaitez une traduction simultanée en français, n'hésitez pas de chercher un paire de casques auprès des hôtesses. And now, to dive into our first demonstration of this morning, we are very pleased to welcome Roctool. Roctool's presentation will highlight innovative molding processes such as heated platens, showcasing a mix of high performance and energy savings. To talk about Roctool's heating technology, we are pleased to welcome Mathieu, the CEO, and Edouard, the Composite Business Development Manager of Roctool. You can ask them questions at the end of the presentation. Gentlemen, the demonstration floor is yours.
Great. Well, good morning, everybody. Thanks for spending some time with us. We'll try to make it entertaining, we promise. With me, Edouard. So Edouard will be more focused on the type of material that we will be molding today. My name is Matt, and I'm very happy to be here. I'm doing the first demonstration, so I might need your help in looking happy and excited. This way, then people will say the first demonstration was the best. So about a year ago, we looked at what are we going to do at the next JEC. And one thing that came to our mind is energy saving, because I think today is something that everybody's talking about. Process flexibility. How can I have a process and I know that based on a new project coming in my company, I'm not going to be stuck with my old process and I can be flexible and mold. So we decided to go across different kind of materials, from chopped carbon to unidirectional materials to 3D knitted composite to woven materials to non-woven materials with the same technology throughout the show. And to do this, we involved some of our partners, some of the material providers that we work with. So we made a selection, we did contact them, and they accepted to work with us. And throughout the show, we're going to show different kind of materials using our technology. So what is Roctool? Roctool, we're a heat and cool technology provider. It means that we work with brand owners to look at what the process can do for their products. We work with manufacturers to help them make good parts, good surface quality, cycle time, energy consumption. We've been in the industry for many years, but this year, we wanted to come up with a heated platen that gives this flexibility of heating and cooling, or maintaining heat, or deciding when is the best time to cool down, and having some inserts that you can play on the heat platen. They can be aluminum, they can be steel. This gives you the flexibility of molding. This is what we will demonstrate today.
Thank you, Matt, for this introduction. Just a quick overview about the installation that you have in front of you. So we have installed a press machine with our RIDS system inside. So it's, as explained Matt, it's a heat and platen with the Roctool technology. And we have on the top of the heat platen some different aluminum mold in this case. So it's a shoe sole mold for the first demo this morning. And we will have the pleasure to use different material for this first demo. Come from, for the first with a Rainbow company. It's a Chinese company. They supply unidirectional carbon fibers and polyamide resin, a mix of unidirectional and weave. And for the second slot during this morning, we will have also the pleasure to test the weight saver material with a large range of prepreg material from polypropylene to PC resin. So for this live demo, we will use natural fibers, exactly flax fibers with polypropylene resin. So we show you for the first demo the use of rainbow material, and we will start in a few minutes. For this installation, you have closed the press, all the Roctool equipment that we use for many the induction generators on this side, and different cooling unit. One is dedicated for the mold, and the second one is for the RIDS system. I think we can start now the first demo.
So just as a reminder that induction heating is a safe technology. Induction is used in many different industries. Actually, one of our partner, part of Roctool, is using induction for welding, can be used for heat treatment, brazing. We have revisited induction for molding. And we use it in a format where here it's compression molding for thermoplastic materials. Obviously, if you do thermoset, we can also use a heat platen to heat a mold that would be dedicated for thermoset molding. We thought for the show we would do a focus on thermoplastics. Okay. So looking at the installation over there, we have a remote control. So Hugo over there, who we did not introduce, Hugo is in charge of the demonstration on the molding side as a Roctool engineer. We have thermocouples that are located on the heat platen where we can monitor the temperature. And we can also have thermocouples inside the mold inserts to know exactly what is the exact temperature on your mold surface based on the temperature you need for your consolidation or for whatever you're trying to achieve with your material. So in that particular case, we need to heat up our platen to about 250 C. And then we will have a heat transfer to the insert to mold our material. One thing to keep in mind, and that's the advantage of the induction, is later during the demonstration, as we cool down the inserts, we also cool down the heat platen. Okay, the heat platen has a heating and cooling integrated, but we don't have to cool it down all the way to ambient temp. We can cool down to another temperature to be ready for the next cycle, where because of the induction, you can just reboost a little bit to get back to your temperature on your insert. So think about the productivity that you get doing this. Here, we're starting from ambient. So the first cycle is obviously the worst, right? But as you go and you make more and more parts, that's when the technology becomes the most interesting. Another point, the induction, you use the energy when you mold, when you're actually doing something with it. Other technologies like electrical cartridges or oil heating, they don't have this capability. Typically, a manufacturer could leave it on for maybe a day or two because it takes too much time to heat up the whole press or the whole platen or the whole tool. Here, you just use it when you need. So if we do an energy analysis per cycle, you will reduce your energy consumption because the energy will be used as you mold. Any in-between cycle is gone. That's a CO2 claim that can be calculated based on your application that you can share to your customer. Or if you're the customer, if you're the brand, you can then do some in-house CO2 calculation per application.
So typically in this first demo, we start to heat at 80 degrees. And now you see on the screen that we reach 260 degrees. So in less than 2 minutes, 30 seconds now. So with the connection of the induction generators, we use in this case a dual zone generator. So it means that we can manage separately the heating system on the top and on the bottom. So typically on this installation, we have a 50 kilowatts of power energy for the top and 50 kilowatts for the bottom. So we use it all the maximum of the power for the heating to reach the maximum temperature rapidly. And we will reach this temperature, the maximum temperature, in a few minutes.
So Edouard, maybe to say about the temperature here for the show, we didn't choose any PPS or PEEK or PEC materials. We stay within nylon, polycarbonate, polypropylene, but still, I mean, the polycarbonate on the chopped carbon goes pretty high heat. But the induction has no limitation in terms of heat levels. That's also interesting. If you do have high heat applications, if you need to go high heat, know that the induction can go to 400 Celsius plus. And with Roctool engineering, we know how to design, and our induction system inside the heat platen has a very particular design to withstand high heat molding. Okay, so that's something to keep in mind. We can go way beyond 250 C.
Again, a few seconds to reach the maximum of temperature of 300 degrees in this case. Hugo, can you send me the resin we use typically? Yeah, we use nylon resin in this first demo. So it's why we need to reach 300 degrees. So now, as we reach this temperature, yeah, we have reached 240 degrees on the top of the molding surface. And you have here the information about the thermocouple integrated in the heat platen. And so, as we reach the maximum of temperature, we can stay at the same temperature for the holding time. In this configuration, we just stay a few seconds, and as we reach this temperature, we start to cool down. So we use for this step dedicated device. So in this demo, we use a C6 equipment. It's a cooling unit with the capability to deliver 100 liters per minute with the temperature of the water at 20 degrees. And in less also than few minutes, we reach demolding temperature in few seconds.
So, Edouard, I don't know if you want to show actually what we're molding and explain
exactly.
that is. So, I think if you can explain, and I'll just show.
In this situation, in this demo, we use a multiply material. So on the external side of the material, we have carbon weave with polyamide. And in the middle, we have 3 different ply of unidirectional carbon with different orientation to have a reinforcement on the final parts. So we have a mix of different material together, and we can consolidate in one time of the material.
We missed the cooling and the demolding.
Oh, yeah. So
we'll get better on the next demo.
The parts finally after consolidation. So you see, of course, the different ply outside, but you have the final parts consolidate and.
So the demolding of the insert was done at ATC.
Yeah.
ATC.
Exactly.
The insert was ATC about. Okay, but a little less when we open. But the platinum then, like we said, if we wanted, here we're not doing production. Obviously, it's a demonstration, so one cycle. But if we want to crank parts, we could have like a feeder with material coming in and the operator having cycle after cycle, keeping the heated platen to some level of temperature. Okay, so here we can see, Edouard?
Yeah.
Thank you.
Take it.
We can see the full consolidation of the part. And also the surface quality where we have a resin-rich surface. That's because there's enough heat, so the resin migrates to the surface and covers. If you try to do that where you preheat materials and transfer them very fast to a cold mold, it's quite difficult to get to that level of quality and that level of a resin-rich surface directly from a pre-preg. So that part, in terms of cycle time here at the show, is 5 to 6 minutes. Using a heat platen, because Roctool, we're known also for the same technology integrated in molds, but here it gives you the ability to change molds and to change inserts as you need.
So for the second live demo, because yes, you will have the pleasure to have a second demo in one, we change the material and we use the material from Weissever company. Weissever is a German company. They supply customized pre-preg material with a very large range of thermoplastic resin and reinforcement. So in this live demo, we like to use natural fibers, but you see also that we will have also for the next demo, we will test another different material like PP material and carbon fibers, PET material and glass fibers, and chopped carbon fibers, which is also the demo for tomorrow to produce coaster parts. So you see also the versatility of the process because we can move from polyamide resin to polypropylene, which is at low temperature. In this case, the maximum of temperature concerning the transformation is around 200 degrees. And so we can, in just a few seconds, change the parameter processor, we change the programmation to switch on this second material.
So we think if we're in a production environment, okay, because here I think the JC, they did a great job to recreate a little bit a production environment. Here's the questions. How much time and effort, if we had oil heaters or electrical cartridges, would it take to reset completely my mold, my machine, to different temperature? What would happen in my day if I have to do that? When do I know that I can actually start molding? So that's what we show with the induction, is really this ability to quickly transfer energy. And here in this case, with the thermocouple, we can program a lower temp because we're doing nylon. And the heat platen would calibrate itself, use kilowatts that is needed to hit to that level. One point about energy consumption. So here we're using 100 kilowatts. Okay? People go, oh, that's a lot of energy. Okay, well, let's take a step back. We need a lot of available energy. There's a big difference between the energy you actually consume and the energy and the electrical installation that you have available. If you buy a car that says that can drive 300 kilometers an hour, you typically don't drive at all times at 300 kilometers an hour. If you do, great, but I don't think you should. So in this case, what we do is we use the full power as we do the heat up. But in between cycles, when we keep the heat platen as a dwell in temperature, right? So let's say we reach that 150 Celsius heat platen, and then we have the inserts, and then we want to dwell. That's 5 to 10 kilowatts dwell energy we're using. So you're 150 Celsius on your heat platen in between cycles where you dwell, you're 5 to 10 kilowatts. And then you're going to reuse your 100 kilowatts from the platen to get back to your 200C in the inserts or 250C, and then again the cooling will cool down, you go back to your 150 or whatever temperature that you want to get back to. So then it becomes a quite interesting way of manufacturing composite parts. Same thing with thermoset. If it's thermoset, you might have like a curing pattern, you might have a holding time that is necessary to snap cure your resin, whatever it is. You can adapt the induction to it and program with your thermocouple the heat and the cool pattern in your cycle.
So we start the second live demo with the PP and natural fibers material from Waste Savers company. So we start to heat in this case. So we like to reach 240 degrees. So you see again that in less than 3 minutes, we start to reach this temperature very rapidly with our RIDS system. And we have for this time a range of power of 25 kilowatts. So we have again 20 seconds before to reach the maximum of temperature. And
so how long is the cooling stage for this one before demolding? 90 seconds. Okay.
Yeah, it's very short.
So the fact that the insert is cooled down and separated from the heated element, you can really reduce your cooling time in general without having to be interfered by the platen itself, because the insert is cooled down on its own. But the platen also has a cooling network to just cool down to the, like we said, that step temperature to be ready for the next cycle. Because if everything was in the tool, then you would need really a lot of energy to go up and to go down every single time. which we do also work on with the Roctool technology. But here, I think that it's a good kind of compromise between productivity and energy consumption.
So now we start the cooling step.
So the cooling temperature, the water is just ambient?
Yeah, it's just ambient. So
okay. So we don't require special cooling or anything. Just industrial water from the factory would be sufficient.
Yeah, normally we can use a temperature of water at less than 20 degrees to optimize also the cooling time. So you see here, we finalize the part and we open the press to demold the part. And as you see, we have consolidated the parts in just a few seconds without also degradation of the natural fibers, which is also a difficulty to transform thermoplastic composite material with flax fibers. So based off our technology and due to the induction heating and the very quick cycle, we are no degradation of fibers and we can consolidate with a very good surface quality this innovative material.
What's interesting on this always is you can really see the heating as being heating, no heating. You can really see next to it how the material is still, you know, raw and where it's fully consolidated.
No, no, but yeah. Thank you, Matt.
Okay, so I think we're reaching the 10 minutes milestone, which we can start to engage in Q&A. Maybe as a quick summary, so the first demonstration was with rainbow materials on unidirectional and woven combined with a polyamide matrix. And the second one was with White Saver on this natural fiber and polypropylene matrix on a woven material. So if there are any questions, now is the time.
We will have just Matt to introduce also the user demonstration and also the different material. We will have also the pleasure to use a 3D preformed textile come from Saint-Gobain Aerospace Company. So we will have on the other live demo the possibility to see this preform in our configuration. And also the use of non-woven recycled carbon fibrous materials with polypropylene come from UO company and Ayate material with the interest to have also a good durability and a short cycle time combined with our technology.
And also the chopped carbon, which I think it's another demonstration tomorrow or something where we just use chopped carbon and we mold it in one shot in polycarbonates. Pretty amazing. So that's throughout the whole show.
Exactly. So we will have the opportunity to show you a large range of different semi-finished products in the case of the thermoplastic composite material. Of course, also we will make the same with thermoset material. Yeah, enjoy.
Yep. So if there are no questions. Oh, there's one. Yep. There's a question right there. Just. Il y a le micro qui ne marche pas pour le monsieur.
Test, test, test.
Now it's working. Hello, Gaspar Zupan from Milan Composite Division. I would have a question regarding the size of the tooling. We see now that this is a small mold. What are the limitations for the molds?
So this is a 600 by 400. We recently have installed a 2.5 meter by 1.5 meter full heated platen, and we have a project for a larger one. So it's all about design. It's all about having a good tool maker that will work to make the heat platen and to machine the channels to place the inductors. And we've got the engineering for our own induction devices that go inside the platen. So we don't have a limitation in terms of size. Then it comes to the economics. How big you need to go and for what. The larger the advantage becomes more dramatic, because if you want to use oil heating for very, very large platen, then it becomes very, very difficult. So In terms of feasibility, we have no limitations. So far, we went to 2.5 meter to 1.5 meter. And like I said, we're going to go bigger.
Any limitations regarding the 3D shaping for this?
So the platen, then, whatever insert you place on it, we can work together to some engineering to make sure the insert will be heated using the platen. So yes, but the insert has no heating integrated, only cooling.
Matt?
Okay,
Yes.
thanks.
As we have again a few seconds, we can explain that for each application and also for the IRIDS solution, we need to integrate completely inside the mold or inductors for the heating element and combine with the water cooling circuit. So all is completely inside the mold. And as you see on this sketch, we have the loop for the inductors. So we try to be close to the molding surface to have the best efficiency of the induction heating. And we combine the heating integration with the cooling line. And typically, it's a design that we made during engineering study, depending on the application.
Network and your heating network.
So we can do every different configuration. In the case of our IDS solution, as it's flat, it's quite simple to integrate inductors inside.
We also have with the generators zone heating capability. So here it's 2 zones, one in the top, one in the bottom. But we could have also a large tool with 2 zones on only one side and 2 zones on another one. I think there was someone else, but I forgot who he was. Okay, so I think we come at the end to this demonstration. We appreciate your time. And if any specific questions, you can come to our booth, which is next door. If it's more detailed and about your own application, for sure, you can engage with our engineering team. Thank you very much for your time today. Thank you.
Thank you
Thank
so
you very
much.
much.
Thank you so much, Mathieu and Edouard. And the next demonstration from Roctool will be at 12:15 and again at 4:15 if you would like to come back. And of course, don't hesitate to visit them at their stand, which is right next door. Very practical. Ladies and gentlemen, our next live demonstration will take place in 15 minutes with Aerovac Composites 1 Process Materials. At 10:45, don't hesitate to come back for the next live demonstration. And if not, enjoy your day at the Jack World.